Today we shall study about the derivation of the metacentric height. First of all, we have to know what is metacenter. Suppose let us give to a figure. This is a body. This is a body that is dipped into the liquid. Part of the body is dipped into the liquid. Then we see this point is the center of gravity and this point of the center of buoyancy. What is the center of buoyancy? Center of buoyancy is the point, is the center of the displaced liquid by the body. This is the volume. It is a part of the volume that is displaced by the body. Liquid is displaced by the body. Now we shall talk about metacenter. What is the metacenter? Metacenter is nothing but after giving some tilt, figure will be like this. When theta is given to the body, then figure will be this type of shown. So first of all, this is action, line of action. Center of buoyancy, due to center of buoyancy, FB force, buoyancy force is acting at this point and weight at this point. Both line of the action lying on same line, but due to some tilt is given to the body, then center of gravity is there. Center of gravity is there. It does not change. It is not changing, but center of buoyancy changes from this point to this point. It is the previous center of buoyancy when theta is not given to the body, when tilt is not given to the body, but after giving some tilt, then B changes to B dash. B changes to B dash. Then line of the action due to center of buoyancy is there, but center of gravity is there. So when metacenter, when first line of the actions, when center of gravity as well as center of buoyancy lying on same line, we are talking about that time. This is our line. This is our line. This is our line where center of gravity as well as center of buoyancy both are situated on the same line, but center of gravity changes. So we draw a perpendicular. From this point. Then we see this line as well as this line intersect at a particular point. This point is the metacenter. It is denoted by M. We are denoting by M. Are you understand? First line of the actions where center of buoyancy as well as center of gravity both lying on the same line, and after giving some tilt, again we are repeating, after giving some tilt, B changes to B dash, so force of buoyancy is acting at this point. So we draw a perpendicular line from this point, and it is extending at some distances. So we see this line and this line intersect at a common point. This is known as metacenter. Okay. When we give some tilt, when some theta is given to the body, then body would like to regain on its original position, come to regain on its original position. If it is in stable conditions. So the rightening coupled due to shifting of the center of buoyancy. Our center of gravity is acting at this point. First, center of buoyancy is this, center of gravity is this, lying on same line, but it will change after giving some tilt. Center of gravity is there, but new center of buoyancy is there. So couple developing the rightening couple due to shifting of the center of buoyancy is equal to FB dash into perpendicular length, FD dash into perpendicular length, because at this conditions our force of buoyancy must be equal to the center of weight of the body, because it is stable, because it is in equilibrium condition, because it is floating into the liquid. Okay, BB dash is the perpendicular distance. So BB dash, what will be the value of this BB dash? As you see, it is theta. BG component of the BG along this B dash M is BG BM cos theta. Component along B dash M, component along B dash M, component of the component of the BM along B dash M will be BM cos theta. So it will BB dash component of the BM along BB dash will be BM sin theta. What will the value of BB dash? BM sin theta. So you know about center of buoyancy force. Buoyancy force is nothing but weight of the displaced liquid, by the body into BM sin theta. So weight of the displaced liquid by the body, rho g into V. V is the volume of the displaced liquid by the body, because let us come to the next stage. Our figure is like this. Body is dipped into liquid, and center of buoyancy is there, center of gravity is there, both line of action lying on the same line, and volume is occupied by this body in the liquid is V. As you see, after giving some tilt, figure will be like this. So some part of the body has come into the liquid, some part of the body, some external part of the body will be come into the water, and some part of the body that is dipped into the liquid will be go out from the liquid, will be go out from the some part of the body that is dipped into the liquid will be go out from the liquid. So our volume does not change, our volume does not change because some part of the body, how much part, some part of the body is dipped and some part of the body is go out from the liquid, so volume will be constant. So rho gv into bm sin theta, it is rho g, it is denoted by w, wv bm sin theta. Okay, now let us come to the ways. When some part of the body is dipped into the liquid, and some part of the body that is dipped, that was dipped into the liquid is going out from the liquid, so due to this cause, due to this ways, couple will be developed at these places, couple will be developed. So wvmb sin theta mb sin theta must be equal to dfb into distance between the centroid of the wedge, distance between the centroid of the wedge. dfv is what? dfv will be w into v wedge, volume of the wedge, because v wedge means volume of this part, volume of this part into distance between the centroid of the wedge, distance between the centroid of the wedge. This is two wedges and centroid of this wedge is there and centroid of this wedge is there, so length between this is 2y by 3, it will be 2y by 3, 2y by 3. So w into v wedge, what will be its value, v wedge what will be its value? So you see this length is the y by 2, this length is the y by 2, and this is theta. Y by 2 component of this along this line, component of this line along this line will be y by 2 sin theta. Okay, y by 2 component of this line along this line is equal to y by 2 sin theta, but theta is very small, so sin theta must be equal to theta. Okay, Okay, then we see area of this vase. Area of this vase, this is the perpendicular length and this is the basis of this area. This is the basis of this area and this is the altitude of this area. So area of the wedges will be, area of the wedges will be half into altitude into basis. Half into altitude will be y by 2 sin theta and basis will be y by 2. So y by 2 into y by 2 theta, it will be area of the wedge. So area into depth is the volume. Okay, area of the wedge into depth of the wedge will be volume of the wedge. So into L, total will be the volume of the wedge, because L is the depth of the wedge. This is the L, upper surfaces का जो L is the length of this upper surfaces. So area of this and depth of this area will be L. Depth of this area will be L. So volume is known into 2y by 3. Okay, W is cancel out. So MB sin theta is changes to theta. MB into theta must be equal to 1 by 2 into y by 2 into y by 2 theta into L into 2y by 3. Theta also cancelled out. Sorry, B into, okay, yeah, V into MB must be equal to 2 cancel out, y square y cube ly cube upon 3 not 3 into 2 6 and 6 into 2 12, ly cube into 12. This is the moment of the liquid line area L into y about its longitudinal axis. So MB must be equal to I upon V, because we see Ly cube upon 12, it is the moment of inertia. It is the moment of inertia of this part of the surface. This part, moment of inertia of this along longitudinal axis. Ly cube by 12. Ly cube by 12 is the moment of inertia of this figure along longitudinal axis. So we have read this is the moment of the liquid line area L into y about its longitudinal axis. So MB must be equal to moment of inertia of the upper surfaces, moment of inertia of the given surfaces along longitudinal axis to the ratio to volume. So metacentric height will be, what will be metacentric height? What will be metacentric height? mg and bg. mg and bg. bm is also derived, have also derived. bm is bm has also derived. So bm is equal to bg plus mg. bm is equal to bg plus mg. bm is equal to bg plus mg. bm is equal to mg plus bg. mg plus bg. mg metacentric point and center of gravity. Distance between the metacenter and center of gravity will be the metacentric height. So mg will be bm minus pg. Then bm is equal to I by v minus bg. mg metacentric height, required metacentric height. Okay.